Thank you, Jelena. First, I wanted to say that I'm really delighted to be back here with all of you, and I'm wanting to thank you for making it possible. And to thank you, of course, for letting me discuss this paper that probably most of you already know. So I'm not very... Okay, so maybe I can be a little bit quicker because I don't want to miss the historical tour. So to represent the major technical and scientific achievement that represent this paper, I draw a very, very classical timeline, but always efficient, that start in the middle of the 20th century with the work of Mrs. Rosalind Franklin, that is always forgotten, but that ends into the work of Mr. Watson and Crick that are not that forgotten, to draw the supposed DNA structure. 20 years later, Mr. again Sanger published his famous technique that rendered the code readable. It's something to do with, I guess, chain-terminating inhibitor, something like that. And in the beginning of the 1990s, the Human Genome Project began, and it took like 10 years to be completed. Just a few years before the advent of the next generation sequencing that probably completely revolutionized the field of genetics. In 2010, so 2005, it's when, no, 1 year before I started to study medicine. And I remember it was revolutionary, this NGS technique, etc. No, maybe in 30 years, 40 years, no, never. So in 2010, the famous 1000 Genome Project that aimed to account for the diversity of genetic variations across different ethnic groups. Again, a famous woman that has not been forgotten, this one, that drawn this incredible milestone for genetic studies, and end of the evolution, this paper. So the landscape of genomic alteration across childhood cancer. It was published in Nature in 2019. It's mainly the work of, Stefan Pfister and German colleagues with international collaborators. And this paper is a comprehensive analysis of pediatric and young adult tumors. It represents nearly 1,000 samples of pediatric cancer and young adults. And the analysis was composed of the data from whole genome or whole exome sequencing. This paper was possible thanks to the gathering of a variety of different cohorts, mainly German cohorts, but also from other countries. So I won't go into the detail of the paper. I don't know if it was expected, but just to draw the key aspect of this publication. So these are the key aspects, and these are the key findings. So they wanted to answer several questions around genomics in pediatric cancer. The first of this question was the question of in what extent these tumors harbor some mutations. And the answer to this question was that the pediatric cancer display a much lower mutational burden as compared to adult ones. One of another key aspect of this paper was that we were able to find around 6% of patients that harbor in the germline DNA, a germline variant that was predisposing to cancer. Another important statement of this paper is that We already knew that pediatric cancer differs from those of adults in many aspects, but this was confirmed at the genomic level that it's not completely different, but there is clearly tendencies of mutational processes, of recurrent genes that are affected, that are clearly distinct from the data that came from adult studies. And at the end of the paper, the author discussed the drug potential of all these discoveries. And the major statement is that there is, if you look attentively, there is a molecular alteration that is amenable to targeted therapies in almost half of the patients. So, what did I choose this paper? Here is the unicorn, sorry, Bob. And I think yes, it's bright. So I chose this paper because I remember it. It was, oh, sorry. Perfect. Like a very blowing lecture. All the panel were very colorful, like even each figure, it's like, I don't know, a rainbow flag. And you should not be colorblind to analyze it properly. So if you go back to the good aspect of the paper, I remember it like something, okay, now we can do everything technically on pediatric tumors. And the science allows us to analyze the tiniest things that we can find in this tumor. So if we can see everything, we will understand everything, and of course we will be able to propose a specific targeted treatment with, I don't know, pills twice a day to each children, and there will not be issues with cancer anymore. It was traumatic, but anyway, I had this feeling at the moment. But of course, it came with some disappointments, so the second unicorn is here. It's not so far away, it's like 6 years ago that this paper was published, and yet today we have to face some disappointment about all of these genomic studies. First, because to my sense, there is currently an actual limited place for targeted therapies in pediatric cancer. Of course, there is some specific cases that benefit considerably of this treatment, but for the vast majority, it's like something that all we had this hope, this immense hope with the advent of targeted therapies, and well, who propose it right now with the hope of cure? And the second disappointment is about the first statement of the paper, that pediatric cancer display a very lower mutational burden, and this statement is to correlate with the failure of immunotherapies, I mean the active immunotherapies with immune checkpoint inhibitors that are basically ineffective in children, except from certain tumor types, probably because of this much less tumor burden that renders the tumor less immunogenic. And at the end, this kind of study also raised a global questioning about what should be the place of such investigations in a personal context, an individual patient context, because due to the fact that there is a little proportion of patients that truly benefit from such analysis, and in a frame of maybe more fair distribution of resources, when should we continue to do that on every tumor? It's an open question, I don't know. Shouldn't we rather finance meta-analysis about, I don't know, those children has the right to go to see Taylor Swift in a stadium 1 week before starting conditioning for HCT? I don't know. But it's an open question, and I would be glad to discuss it with you if we have time.
Any comments?
I have a question. I mean, I fully agree with you what you said. my question would be, how many analyses do we have to do to find out one patient we successfully can treat?
With a targeted therapy?
Yes. Do we know? Do we have those numbers?
I think that we know now that we can do it in certain type of cancer. Searching, I don't know, with the BRAF alteration, but in widespread cancer type approach, I'm not sure that any patient benefited truly from maybe 1 over, I don't know, 1,000.
Yeah, that's the question.
Yeah, but I don't know the answer.
I think what we have learned from Stefan Pfister and the INFORM study is that there are certain subtypes of pediatric cancer, like Ewing sarcoma and rhabdomyosarcoma, in which we don't find any targets that are of benefit then for the patients. But of course, I think it was important this study has been performed to learn about this. But the results are disappointing, as you all know.
But do you, in new countries, have programs that propose wide genomic sequencing of tumors in patients? I don't know, when they relapse or something like that. When they relapse, okay. Okay.
Very bad, like some of those with a very poor outcome. Those they go directly.
We also have
setting.
it in the routine care now in France, but I don't know how many patients benefit from it. Yeah.
And besides, you did very charming presentation. I think you just underlined 3 important things. Question of predisposition, which is raising nowadays. Also, the question that you just posed now. And the third one, does anybody know the drug was designed according to pediatric population, or you know about any novel therapy or innovative therapy that was designed only in adults and then translated to the kids?
Just for the kids, right?
Mm-hmm.
Like, did you choose map on did you choose?
Not that I know. Rituximab?
Dinutuximab.
Good. Good. And any other?
Like, NTRK were done in adults, and then it was done in now currently used in children at the same time.
And do you know how many novel drugs do we have?
There are a few.
No. I mean, in adults and pediatrics. 4 numbers. So, I don't know, it's now even in thousands, and you counted 2. So the third good point is something that Ruth and Gilles were doing about oncopolicies and trying to ensure the independent studies for kids, which we all need. And I don't have the answer, maybe somebody has. How shall we proceed? Does every kid deserve the whole genome sequencing? What do you think?
It's getting cheaper and cheaper as well. So I think, as Andisha said, we learn a lot from this. Maybe not what we want to have, but still, like with the predisposition, as you said, I think this is important. And as it's getting cheaper and cheaper, so I think one should continue. But maybe not for everybody, because we cannot afford it at that time now, but maybe later.
That was a research project, in fact. Yeah. This was a research project from Stefan Pfister. It was just to show that this whole genome sequencing and all the other analysis that they do, that they not only do NGS, they now do drug sensitivity testing and many other things, that this is feasible. This was a feasibility study. And I think this is very important to mention here.
If no other comments, thank you.
Thank you.
And I think Alessandro is the next one.